Hi guys, let me take a few minutes and go over your sampling distributions quiz. So the first question is just the definition of a sampling distribution. So it is the distribution of all of the values taken by the statistic in all possible samples that are of the same size and come from the same population. Number two is A. Histogram A represents a distribution where the statistic is unbiased, so the true value is actually in the center, but there's relatively high variability. Notice C is also unbiased, but there is less variability around the true value. Number three is D. D represents a distribution of a sample statistic that's biased but has relatively low variability. Notice both B and D are biased. So again, the asterisk marks the true value of the population parameter. Both of them are not centered around the true value, but D has less variability. Number four, that correct answer is spread. So remember that n is in the denominator of both of the expressions for the standard deviation for the sampling distributions for both proportions and means. So as n grows, the spread as determined by the standard deviation gets smaller. So in question number 5, these are for proportions. These are the values you need to calculate in terms of determining whether or not our sampling distribution is approximately normal. So you want to take n times p, that would be 20, and n times 1 minus p, that would be 30. Both of those need to be greater than or equal to 10. The center of the sampling distribution is just the true value of the proportion, that's 0.4. Here is the independence condition, 10 times the sample size, which is 500. That's certainly less than the number of students at WHS, and that's the condition that allows us to be able to calculate the standard deviation. So you should show your work. So that's the square root of p times 1 minus p divided by n. So that comes to be 0.07. On the back side of your quiz then, I didn't want you to work too hard on question number 8. You want to find the probability that one randomly selected household owns 2 or more pets. So this is the correct probability statement. You could have also said the probability that x is greater than 1. But literally all you had to do is add up the probabilities. So literally the probabilities for 2, 3, 4, 5, 6, and 7, this is a discrete random variable, so you can add those up to get 0.4. So the sampling distribution for the mean is approximately normal around the true center of 1.65. We're told that's the center. And then the standard deviation of the sampling distribution would be the standard deviation from the population, 1.85, divided by the square root of the sample size, 35. So in total, that's 0.31. And then here are the conditions. So the sampling distribution is based on these assumptions. So randomness is already satisfied, but this is the independence assumption, or the independence rather condition. Guys, some of you just told me a story about why you believe that the number of pets in one household would be independent from a different household. But in fact, what you really need to do is do the calculation. Just like on the front side, 10 times the sample size is 350, and that should be less than or equal to the number of households in this large suburban area. And number 11 then, by the central limit theorem, the sampling distribution is approximately normal, distributed normally, because the sample size is greater than or equal to 30. And then, like so many times we see, we're going to calculate a probability based on the normal density function. A number of people missed this one. A correct probability statement, this isn't about x. This is about x bar. So your probability statement had to be, what's the likelihood that the mean number of pets is greater than or equal to 2? So there has to be x bar, not just x. You need to turn that into a z-score. So 2, take away the mean of 1.65 divided by the standard deviation of 0.31. You should be using your mean and standard deviation from number 9. That gives you a z-score of 1.13. So in terms of the graph then, you should draw your normal distribution. Mean of 0, standard deviation of 1, those should be marked and labeled. Your boundary of 1.13, there is the z-score, that should be marked and labeled. And because it's a greater than question, we should shade above it. You can use the shade norm command with a lower boundary of 1.13 and an upper boundary of, say, 10 to get your area of 0.129, and that's ultimately the probability we were looking for in question number 12.